All right, good morning. I'm planning on doing LeetCode contest 291 from last Saturday. So here we go. All right, these guys up. Okay, remove digits from number to maximize result. Okay, remove exactly one digit. Decimal form is maximized. We want to remove the 3 instead of the 1, though. What the heck? On occurrence of digit. Oh, you have to remove the 3. Okay, you have to move the 1. If there's only 1, it doesn't. There's no choice. Okay, so you can remove one digit from 1 to 9. There's no zeros. You remove first instance of the digit, right? So, hold on. 6:03 a.m. The game plan, I perform a linear scan of the string S, the input string. And remove the leftmost, like the first leftmost instance where the resultant value without, right, with the right, removed is greater. I think so, right? So example 1, if there's a 3 at the beginning, we most certainly would not want to take this one, right? So let's do this. If S is equal to 3, 1, 2, 3, then it makes sure this one makes sense to take the rightmost 3 in this case, where taking a previous instance of 3 is suboptimal. Right, so if the neighbor to the right of it is bigger or doesn't exist, yeah, so we'll just do a linear scan and then remove the last instance if we cannot make a previous improvement to the left. Okay. In. Okay, so if I sub I, which character can we remove? Do this. If it doesn't equal X, we can continue. Otherwise, S sub I is X. It's a candidate for removal. substring takes a length. We want the length from n minus take plus 1. Something like that, I think. If I plus 1 less than n, and I don't know if I want that or not. You want it bigger, right? I want to maximize this thing. S of I is less than S of I plus 1. Then we want to take that one. Always take it. Oops. Take equals I. Break in this case. So we'll take the very first one if it improves it, or we'll just do the whole thing and take the very last one. And then let's say if we take the first one, then in this case, let's say it's 3, 4. So in this case, we want to take the first one, right? So take 0. That's cool. 0, 1, 2, 3, 4. Okay, so n equals 4, take equals 0. Take plus 1 will be this guy, right? Take plus 1 equals 1. N minus take plus 1 then is 4 minus 1 equals, 4 minus 1 equals 3. Take from index 1 for length 3. 1, 2, 3. Okay, so that does look right. And in the case we want to take the rightmost one, all right, so n equals 4, take equals 3. So 0 to 3 non-inclusive. Take these guys, and then take plus 1 will be 4, and then n minus take plus 1 is 4 minus 4 is 0. Okay, so that works out, I think. Let's see what happens. 12 is correct. 2, 3, 1, and 5, 1 for the other ones. 2, 3, 1, 5, 1. Okay, looks good. Yay! Okay, 6, 2, 3 to 6, 11. Yeah, about 8 minutes. Oops. For AC. Yay! Okay, so all right, we can clean this up too, right? If it equals this, a little bit cleaner. occurs, then break. I don't know. It looks okay. Whatever. Let's move on. I don't want to perfect it. It's good enough, right? S, X, let's do this. 6:13 a.m. Okay, so if S sub I is equal to X, and take equals 0, take equals I, if I plus 1 is less than N, and S sub I is less than S sub I plus 1, break, return S substring of S, which we can format together. From 0 to take non-inclusive, and then from take plus 1, let's just make this thing K. K is fine, right? K will be the value that we take, 0 to K, K plus 1, till the end. Okay, that looks right. Okay, that looks good. 6:13, 6:14 a.m., 2 minutes. Okay, JavaScript. Okay. Use the string interpolation. K plus 1 onwards. I, if I plus 1 is less than N, and S of I is less than S of I plus 1, it'll break. Looks good. Okay. JavaScript, Kotlin. And length. Okay. Return x dot substring 0 to K non-inclusive. Substring K plus 1. This one is listening in, and this is I. Okay. Looks good. Rest. Turn string from 0 to K. The return format. String from a sub k to the end. For I in n. I plus 1 is less than n, and s sub I on s equals s dot chars dot collect. Something like that. Consider giving s a type, cannot infer type. S can be a vector of characters. Card bound introduced by this call doesn't have a size, no, a compile time. Ah, crap. Char string from. Thought that would work. Let's come back. Solve rest, right? I want to get to the other questions. I don't want to just hang out on Q1 and Q2. Few solutions. Let's call this in K. 1. K. I wonder if this works. Do I need to end? That's fine. Yeah, it's cool. Uh-oh. Unknown error. That's weird. Okay. Kotlin, JavaScript, Python 3, C++. Okay. Python 3. JavaScript. Kotlin. Okay, and then let's put a description here. Perform a linear scan of the input string S to find the index, optimal index K, such that removal of the K results in the max integer value, maximal value. whenever s of I equals X and I is a candidate for K. And we take the first instance, I guess the leftmost instance, right? The leftmost, I guess, significant digit. We take the leftmost significant candidate. That sounds good. I perform a linear scan of the input string S to find the optimal index K, such as the removal of the kth character of S results in the maximum value I. Whenever S of I is equal to X and I is a candidate for K, and we take the leftmost significant candidate. Okay, and then we'll fix this up in Rust next. Okay, so that took 23 minutes. 23 minutes for Q1 and on to Q2 with 1 hour, 7 minutes remaining in the contest. Okay. Minimum card pickup. Let's see. Given an integer array of cards. Okay, so we should be able to do a linear scan and then have a counter as a map. Okay. Use a map M as a counter, right? I should pre-process the input. Each value X of the input array A. Then use I guess then consider the adjacent difference. Is it adjacent difference? Hey, let's not do this. Let's actually do pre-process input using a map M as right to track each index of each value X in the input array. Then consider the adjacent difference of return the minimum adjacent difference. The index. The overall index minimum adjacent difference. Whatever, that's good enough. Okay. That's the game plan. Let's see, 6:28 a.m. Game plan. Okay, 6:28 a.m. and minutes for the actual implementation. Let's go. Using map is unordered map. All right, so map M. So auto X A. So hold on, let's do this for auto H index. Size. Oh, it's actually just do this VI vector. So M sub A sub I dot push back I. Okay, and then do the adjacent difference of each of these values. So for auto I0, best equals 20. Let's do this. 29 plus 7. Best equals turn best less than best, otherwise 1. I is less than or equal to 9. I. Let's see. Auto J is 1. J is less than M sub I dot size, right? That ith bucket. It's J. Print our brackets around this guy, so we can have a candidate as an intermediary. Candidate is the delta between M sub I sub J minus 1. Difference between this and M sub I sub J. Jth index, that one. It's the adjacent offset of the indices. Best equals minimum best candidate. Okay. 3, oh, it's 4. Oh, it's that minus that inclusive, so it's plus 1. I did J inclusive. And then, uh-oh, absolute difference between that plus 1, right? Okay. And then -1 for the other input. There's only one instance. Okay, and then let's try another. Let's try this. How about I put a 1 there? 1, 2, 3, it should be 5. Okay, that looks good. Oh no. Output is -1, but I expect 3. Okay. Why did I miss 70? What the heck? Oh, I'm only checking 1 through 9. Okay, oops. Okay, so 628, 631, 631, about 3 minutes for implementation for wrong answer. Oops. I was only considering the single digit value 0 to 9 inclusive. Okay, so let's fix this up. Consider all values in the map. For auto x, comma, underscore, take it by reference. Since it's a vector, I don't want to copy that thing in the map. M sub x is the key. Right, x is the key. X, and then this guy can actually be I index, we don't need a J. So the previous adjacent index, current adjacent index, subtract those, and then actually let's do this. Current minus that guy plus one for I, J inclusive. Okay. This should be cool, but then this one should also be cool. All right. Yay. Okay, AC at 6:33 a.m. Alrighty. Let's do this fast. Fast is less than 1E9, 7. It's cool, right? Whatever. A little bit shorter. Okay, that's cool. Let's do this in Python 3. All the others here real quick. Fast equals 1E9, 9 plus 7, integer. Let's do this actually. It's cool. All right, right, whatever. I'll do it consistently. Best equals that. Return best if best is less than this, otherwise -1. And then for m equals default dictionary of list. And for I in range A, m sub a sub I dot append I, and then for x underscore x and m dot keys, or I in m sub x range 1 to the length of this bucket, candidate is m sub x sub I minus m sub x sub I minus 1 plus 1, right? Plus 1 for I, j inclusive. Best equals minimum of the best candidate. Okay. Looks good. Yay. Okay, JavaScript. A best equals number 1E9, 7. Turn best is less than to this. This is fine. Infinity. Actually, you know, yeah, we can do just infinity, right? Infinity. That's cool. Best is less than infinity. Best is I think 1. Let's see, MLB, our mutable map. Let's do the same. Equals map for let I 0, dot length, right, and m dot set a sub I. Hold on. If not, m dot has a sub I, and set a sub I, a new array, and then m dot get a sub I dot push I index. Okay, and then for let x list of x of map, and all the indexes of x for let I equals 1, I is less than m dot get x dot length I, candidate is m.get x sub I minus m.get x sub I minus 1 plus 1, right? Plus 1 for I to j inclusive. Best equals math dot min best candidate. Okay, that's good. Yay. Kotlin. Okay. Best equals 29 plus 7 dot 2 int return if best is less than. Let's do this. Infinity is an integer, which is equal to that. Best is less than infinity, we'll return best, otherwise return -1. Then for I in 0 until a dot size. Create our map. Our m is a mutable map of integers to a mutable list of integers. Okay. M sub a sub I dot get or default mutable list of int dot add I. All right, and then for x underscore in m or I in 1 until m sub x size. Candidate is m sub x sub I minus m sub x sub I minus 1 plus 1 plus 1 for I, j inclusive, that range of adjacent differences, right? And then best is the minimum of itself in that candidate. Okay. Uh-oh. Get or default. Oh, okay. Get or default. No assertion operator dot add. Oh. Oh, okay. These ones too. That thing is not going to be null. That thing's not going to be null. Get or default. Oh, m sub a sub m dot get or default a sub I, the value of x and a, right? Uh-oh. That does not look right. Get or default. What? M sub a sub I. If not, m dot, oops, m dot contains a sub I. M sub a sub I equals mutable list of integers. M sub a sub I, no assertion operator dot add I. Okay. That's good. Okay, let's post this and get on to Q3. Okay. A few solutions. Kotlin. JavaScript. Python 3. Python 3. C++. Ooh, I didn't even try Rust. Maybe I'll try Rust. Worst case, I'll just come back to it and eventually figure it out. Right, okay, so perform a linear scan of the input array A and use a map M to store each value's index I. Then find and return the minimum adjacent difference. Right, of index values. That's good enough. Kidoki, JavaScript. 3. C++. Okay, let's do REST. Okay, let's finish this up and then go grab some more coffee. 6:44 a.m. Let mute m equals use std collections hash map new let mute best equals billion and 7. Best is less than that, return best, otherwise return -1 for for I in 0 length. When not inclusive, let's say m dot entry a sub I dot or insert vector dot push I. Okay, and then for the keys of the Rust map, hash map keys. Okay, cool. For x and m dot keys for I in 1 until m dot get x dot unwrap dot length what this and a get x let index equals this guy for I in 1 dot index dot length candidate equals index sub I minus index of I minus 1 plus 1 plus 1 for I to j inclusive. Best equals min best candidate. The comparison minimum. Okay, something like that. Expected I-32 found U size as I-32. Yay, okay. That wasn't too painful. Woo, all right, getting a little bit better at Rust. 6:48, about 4 minutes. It's pretty good for me for Rust. Yay, okay, cool. Turn green, right? Okay. All right, cool. Stick that there. Okay, it looks good. And on to Q3. Okay, 43 minutes left. Okay, so about 43 minutes remaining. The contest. Q3, that should be plenty of time. Okay. Let's see what we got. Actually, let me take a break. I'm gonna go get some more coffee. Okay, music going here. Okay, given array numbers, K and P, return the number of distinct subarrays that have most K elements divisible by P. Okay, so it sounds like we can do a sliding window, IJ, and then keep track of how many elements are divisible by P within the window. And so we have to shrink the window on the left side as we add to the right side. So always increment J and then increment I as needed. There are different links, or there exists at least one index I where this sums of one, two arrays are said to be distinct. The number of distinct subarrays. Distinct subarrays. There exists at least one index where they're different. A subarray is defined as a non-empty contiguous sequence. So you can use no one says 0, 3, and 4 to this blank. Okay. K2s. At most. Oh, okay, so we might want to use inversion for this one. So if this entire subarray has too many, this one is okay. 2, 2, 3, 2, 3, 3. As you expand the window, count it, count it, count it, count it. Then it's too big. On the next one, there's a violation. So shrink it. But then how do you not count the overlapping values more than once? So, okay, the array length is only 200, so it's not like 500,000 or something. In this case, we could go back and then just count them over and over again, because 200 is pretty small. Okay. Naive sliding window algorithm is expected to avoid TLE since the cardinality, right? The cardinality of the input array A is at most 200. All right, so I, J, while constraint, right, the problem statement is valid, there exists less than or equal to k values within the window which are evenly divisible by p. K elements divisible by p, right? Most, okay. Whenever we find a violation to this rule, then we shrink the window to immediately and only contain the I plus 1 piece of I plus 1, right? And move that over. So in this case, in example 1, right? So we grow the window, grow the window, grow the window, grow the window. It's okay, it's okay, it's okay, it's okay. And then that one is no good. So here's our window. And these guys, right? 2, 3, 3, 2. Those are all cool. So plus 1, plus 2, plus 3, plus. This is plus 4. 1, 2, 3, 4. Right, size of that counts. 1, 2, 3, 4. And then we move. This is I, and this is J. Right, we'll move I forward. I here. That guy's okay, that guy's okay, that guy's okay, and that guy's also okay. So this guy, this chunk, it's 3322, which is plus 4. Right, this guy also okay, plus 4. And then we'll move I forward again, right? Right here. Right, these are okay, okay, okay. To J. This guy's plus 3. Hey, how does this work? Hold on. 3, 3, 2, 2. Oh, it's not a distinct subarray. Okay, so 3. Okay, so we need to use a set for each subarray count, right? Use a set of string for each sub array, right? Count. Uniqueness to count only once. Okay, so what that we add is 2, 2, 3, 2, 3, 3. Or actually, let's just do this. These are going to be converted to string, right? Nope. Something like this, something like that. 2, 3, 3, 2. 3, 3, 3, 3, 2, 3, 3, 2, 3, 3, 2, 2. Plus 2. 3 already exists, so and 3, 2 already exists. 3, 2, 2 is 3, 2, 2. Okay, so we have 9. I start here to J. That's cool. 0. Oh, that one's good. That one's good. It's okay. It's okay. All right, so it's plus 2, plus 2, 2, and then 2, 2. Oh no, just plus 1. Plus 1. Plus 1. Just 2, 2. Is it 2, 2? Because we already have a 2 there. 2, 2, 3, 2, 3, 3, 2, 3, 3, 2. 3, 3, 3, 3, 3, 2, 3, 3, 2, 2. 3, 2, 3, 2, 2, and then 2, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 9, 10, 11. 9, 10, 11. 9, 2, 3, 2, and then 3, 2, 2. 8, 2, and 1 is 11. Okay. So that's the game plan. How much time is left? 31 minutes. Okay. 31 minutes. 1 minute remaining for implementation. Okay. That's the implementation. Using set is an unordered set of strings. Set scene. Scene.size. Right, return the cardinality of the set of scene. Do our sliding window with a map. Unordered map would count the occurrences of divisible values within the window, and then with the IJ. Size 0, J0, while I is less than N, we'll count them up, perform the sliding window until there's a violation to the constraint. Okay. While J is less than N, count it divisible. M sub A sub J. Wait, hold on. How am I going to use this map? The map is going to track the amount, I don't know if I need a map, then just the count of divisible values, right? Yeah, map, hold on. Count is 0. And the count of divisible values is less than or equal to k. Count plus equals not a sub j plus plus modulus p. If count exceeds k, right? J equals plus plus I. To the next one, break upon violation to that constraint. Right, you expand it as much as you can. If you can no longer expand it, you shrink it back to the next I. Okay, and then our set of what's been seen, auto take is just what we take. Take, and we can append on to take the value in a comma. Let's do this actually. O string stream OS. Otherwise, OS will output to this guy. X equals a sub j plus plus. X is cool. Seen that insert OS string so far. On to the next J after that, and do it again. Okay. Yeah, that looks right. Let's see what happens. 11, that looks good. And then 10 to the other one. 11 and 10. Okay, cool. So yay. Okay, cool. That was pretty fast, actually. Let's see, 31 minutes for implementation, and then got it done. So AC, 25 minutes left. So I'm gonna know that took about 6 minutes for implementation. Yay. Okay, so that's cool, right? Sliding window, and then keep track of the count, and then resetting the value backwards. Okay, yeah, let's just do this real quick in the other languages. Distinct count of what's been seen, right? That turn length, cardinality of what's been seen. Okay. And let's do n equals length of A, I equals 0, j equals 0, while I is less than n. Count is 0, j equals I equals I plus 1, j equals I, equals 1, while j is less than n. Count plus equals int not x equals a sub j plus equals 1, x modulus p, that's cool. If count exceeds k, then we'll break. Otherwise, if it's cool, then scene dot add the formatted string. Oh, spin. Hold on. I want to be take what we take. Scene dot add join the string. Character or x and take something like that. Uh-oh. There we go. Something like that. That does not look right. 1 and 1. Let's print what's been seen. What's going on here? Nothing has been seen. Oh my goodness. Count exceeds k. Count take. X is evenly divisible by p to increment the count by 1. One if else 0. Does that work? No. What the heck? I is less than n. In set. Add. There's nothing in that set. J is less than n. J. What the heck? What the heck? I J count. IJ count. That is right. The logic looks correct, but that add. Oh, we're not pushing anything to take. That's why. Okay. Take that appendix. Okay, that looks good. Actually, append onto what we take. T is good enough. Okay, and then let's delete this guy. That looks good. Uh-oh. It's 14, but we expect 15. Strange. Wrong answer. Divisible by 6. By 6. 14. 15. Evenly divisible by 6. Modulus P equals 0. Evenly divisible by. None of these are evenly divisible by 6, are they? 1, 2, 3, 4, 5. 5. So it should be 5. Some of the series 1 to 5 is 5 plus 1. N times n plus 1 divided by 2, right? So n equals 5, and n times n plus 1 is 5 times 6 divided by 2 is 15, right? That's what I would expect. So why am I getting 14 then? The heck? If count, print I, j, right? I don't expect count. I, append, oh, x comma, append x comma, right? F x comma. That should do it. Okay. Aha. Okay. That looks good. Taking a while. I expect it to be accepted though. Okay. I'm a little concerned there. Okay, cool. All right, let's do this. Let's go, let's go, let's go. Come on. Finish this up and I'll take the kids to the bus stop. Let's see how much time we got left. 15 minutes. Okay, count distinct. So length in equals a dot length. 0, 0. While I listen in. Okay. Scene is a new set. Turn the cardinality of scene. And while count goes 0. Count what we take, right? Take 0. While j is with an n. X equals a sub j plus plus. Count plus equals number x modulus p 0. If count exceeds k will break early. Otherwise, take just a t, take dot push x comma x comma it's okay, and take push x comma scene dot add t dot join to string. Okay, then when we break, we'll do plus plus I, j equals that guy. Okay. Do example test cases, should be 11 and 10, that's good. Yay. Okay, Kotlin. Size. J equals pair 0, 0. Our scene equals mutable set of strings. Return scene that size. While I is less than n, while j is less than n. J I R count take pair 0 mutable list of integers which will join together with commas, right? Okay, cool. So x equals a sub j plus if x modulus p is 0, 1, 0. If count exceeds k, we'll break early. Otherwise, we'll take it, t dot add x and scene dot add t dot join to string comma separated. Okay, that's good. 10, 11. Taking a little while. Oh no. Okay, Kotlin TLEs. Go figure. All right, whatever. And then let's post this real quick here. Few solutions. Use a sliding window J. Since n is at most 200, we can use a sliding window ij to find all Kotlin, JavaScript, 3. Ooh, I could go back and do Rust. And then I didn't have enough time to get to Q4, unfortunately, so I'll have to upload that one here in a bit. Okay, we got 9 minutes. Stick these guys in here. Kotlin TLDs, go figure, whatever. Might be a problem with online judge. And then also, this is not really that efficient of a solution, right? We're always going backwards to each ith candidate to find them all over again. So is somewhat redundant. Redundant and naive, I suppose, but whatever. It's accepted, so. Okay. Good. Eight minutes. Okay, I'll do the rest later on. And I'll probably call it a day now. Catch you next time.